All right, welcome everybody to week 2, day 2 or 3, depending on your perspective. I found this interview with Fergus Urquhart, like back in the day. He told me that he thought people from UC San Diego were pretty good programmers and wanted me to come up to Orange County to meet with him and maybe talk about working for Black Isle and Baldur's Gate, probably 2 at that point, or Icewind Dale or something. So it's kind of cool that I saw that interview. It's kind of like an alternate life path that I could have gone down. I decided to finish grad school instead and become a professor. So yeah, there you go. So we're going to have a very important lecture today. The lecture today is on proper class design. And this is something that is going to sort of encompass the rest of the semester. Everything we do in this class, except when we're lazy, which is maybe sometimes, we'll use what's called proper class design. We're going to move from the CSI 40 way of doing classes to the CSI 41 way of doing classes. So let's say that we've got an asteroid. And this might look familiar to you. It's from the SDF assignment. We're going to have a bunch of asteroids out there. They got X and Y locations. I could say asteroid Bob is equal to 3, 4. And I could see out like Bob dot X, like that. Any questions about this? Anyone know what Bob dot X is going to print? You know? The value of X, yeah, but what is it? I'm initializing it right here. It's going to be 3, yeah. And I could write a member function on this that might tell us how far away the asteroid is from 0, 0. I can make a member, maybe float, and whatever. Maybe call it length or maybe distance or something like that. And I can have this return the square root of, what's Pythagorean theorem, right? Square root of x times x plus y times y, like that. Or if I want it to be even more, hypot. I was thinking one step ahead and just typed CMath and hypothesis available. And return hypot. Like that. Okay. So this function here is going to return the square root of x squared plus y squared, which is going to be what for Bob? So if we see out Bob dot distance, what value is this going to? 3 times 3 plus 4 times 4. What? Random number? No, it will return 5. So this is a classic 3, 4, 5 triangle. So this is CSI 40 way of doing things. This is something called a pod or pods, which stands for plain old data. Sometimes you'll see it called pods, a plain old data structure. Either way, this is the CSI 40 philosophy of doing classes. It's pretty similar to how C does it. So if you're living in C world, then this is pretty similar to how they do it, except they don't have member functions. These functions would be outside the class, but it's kind of the same idea that you have in C world. So what we're going to do today is learn proper class design. So we're going to do the same thing, except instead of calling it an asteroid, I'll call it a point, because it's a point in space, really. There's really very little difference. X, Y, and I'll even just Y3, Y, and P, and put this into the public section. What is the difference between a struct and a class in C++? What is the difference between a struct and a class in C++? Struct is public by default. Yeah, the default permissions on a struct is that it's public. So if I were to switch this asteroid here to a point like this code won't compile. And the reason for that is because classes are private by default. Every member variable and every member function of a class is private by default. Private means this cannot be accessed outside of point. Okay. So main here can't see bob.x now. So what we have to do if we're going to do proper class design is this. Proper, and I'm going to put quotes around that because exceptions are numerous. Okay, I'm just showing you kind of the general approach to doing these kinds of things. So step one is put all your member variables in private. Some people type private like explicitly. I don't know why classes are private by default. So you put all your member variables in the private section. You write what is called a constructor. And then you're going to write getters and setters. And then maybe whatever other functions you need, like distance or something like that. So let's talk about constructors. Constructors are special in C++. They are a special function. A constructor, or C-store, which people write when they don't want to write out the whole word for constructor, is a function with the same name as the class and no return value. So if I make a function, a member function here called point, notice there's no return value on the function, and the name of the class and the function is exactly the same. If you did this, it doesn't work, right? You have to make sure even the capitalization is the same. And let me explain what a constructor is after I write it really fast. So this function gets called automatically when we make a variable named point p or whatever. So if I come down to main down here, and I said point p, this secretly calls the constructor. So this is actually really useful, because constructors can be used to guarantee that your variables are never uninitialized. Okay? So, so I've made here a point class that has two variables in it, and the constructor here is going to get secretly called here. So when I make this variable here, it's going to secretly call the constructor, and it's going to secretly set p.x to 0 and p.y to 0. These are really, really useful for initializing variables. So if I were to do something like this, cout p.distance, Sarah, what is this going to print to the screen? So I'm going to print out the distance that p is from 0. How far is p from 0? It looks like it's uninitialized. If all you could see was main, you'd be like, I don't know if that variable has an x and a y location, but it does. The distance is indeed 0, because secretly, because what this does, it secretly calls the constructor, which sets p.x equal to 0 and p.y equal to 0 as well. So if we say, hey, how far is 0, 0 from 0, 0, the answer is 0. So if we compile this code and run it, you'll see that we get 0. Okay. Constructors can also take one or more parameters. So we can make another version of the constructor. It looks like this. X is equal to new x. Y is equal to new y. So it's going to take two parameters. And it's going to set x equal to the parameter called new x, and it's going to set y equal to the parameter called new y. And so we can call that one by doing something like this. So this is going to call, see how I pass two parameters to the constructor? If I don't pass anything, if I just say point p, it calls the default constructor. This guy up here is called the default constructor. And this is called the two-parameter constructor. So down here, I have two parameters, so it calls the two-parameter constructor. It sets p.x to 3, it sets p.y to 4. So if I were to now print out the distance that point P is away from the origin, what do I get? Answer is no. Operators are standing by. It is indeed 5. So this will print 5. Now, there are ways of not having to repeat yourself, which maybe I'll show you in a little bit. It does get annoying making a 0 parameter constructor, a 1 parameter constructor, a 2 parameter constructor. But for now, we'll just lay off there. There's also something called initializer lists we'll get to in a little bit. But I want to show you this first. What if I only passed 1 constructor parameter? Is that going to compile? Pay no attention to the red, angry red mark to the left side of the screen. What if we didn't have the 2 parameter constructor and we kept the P34? Great question. You have to have a matching constructor for it. So I don't have a matching constructor for the, I don't have a 1 parameter constructor here, so it won't compile. And so, Sally, to answer your question, if we put a 3-4 here and we did not have U, then it will not compile. Because you're trying to call the 2 parameter constructor and it doesn't exist. So it won't work. So if you do want, I guess I can show you now. I'm going to show you the flexi parameter constructor. This is the top tier method. Yep. This is how elite people will code. Actually, a lot of them hate this, but you know, whatever. It's one simple trick that doctors hate. So, what did I do right now? Well, if I don't pass a parameter in, it will pick up whatever default value I put there. So if I did this, what value are x and y going to have? I didn't pass any parameters in at all. So what do x and y get set to? 0. It'll always be 0. Yeah. These are the default parameters. Okay. So p.x is set to 0. p.y is set to 0. What if I pass in 1 parameter? Which one of these do you think it's going to be? Do you think if I pass in 1 parameter, it's going to go in for the first parameter, x? Or do you think the 10 is going to go into the second parameter, y? Z? So who gets the 10 when you got 2 possibilities here? You thought it's not going to compile? It wasn't a second ago. That's why I added the default parameters, Sally. With these here, if I don't provide a parameter, it will put one in for me. So this is usually how I write my constructors. I usually just write 1 constructor, and I give default parameters for each one. So if I'm missing any of them, then rather than not compiling, which is what we had a second ago, it will default y, in this case, to be 0. So if you pass in 1 parameter, that will set the first parameter to 10. Okay. That makes sense, Sarah? Cool. What if I passed in 3 parameters? Is that going to compile? Nah. The flexi parameter only goes up to 2. So this will work with 0, it'll work with 1, it'll work with 2. It will not work with 3 or more because it only has 2 in it. So red arrow says down. I know, right? I need to turn off commander of completion to make this work. Okay. So 8. So what is the distance here? What is that going to print out? Anyone know? Trigonometry? If a 3-4 triangle, the hypotenuse is 5, what is a 6-8 triangle going to be? Cool, 10. Yes. Good. Now, I do want to mention an FTF, a WTF alert, for those of you that did World Taekwondo Federation. Taekwondo. Some people name, some monsters name their parameters the same as the member variable. In other words, they pass in a parameter named x, and they pass in a parameter named y. And now, how do we know which x is which, right? Like, is it my x, or is it the parameter x, right? And so you can disambiguate it by using a this pointer like this. I don't like writing code this way. However, it is very common at another institution here in Fresno, at the state level, let's say. So you can do it this way. It's a coding style. Like, I really am sort of agnostic on coding styles. I mean, I got opinions, but like, if I have to work with somebody who has a coding style that does this, I can work with it. It's fine. And so there is something called a this pointer that points to me. So this is saying my x is equal to x. And the rule in C++, the rule for shadowing in C++ is that if you have two variables with the same name, the one in the nearest scope wins. So when we refer to just x by itself, we're referring to this x here. This one is in a further out scope. And it is allowed. The only rule is you cannot have two variables with the same name in the same scope. So you cannot do integer x, y twice, right? Like you can't, like that's not allowed because you've got two of them in the same scope. But for those people who want to watch the world burn, in other words, people who want to have job security, integer x equals 42. Let's play a game like in Saw, right? Everybody, what value is this going to print to the screen? X is equal to what? Hopefully you can all answer this question. If not, CSI 40 is retakeable in the fall. 42, good. Okay, now watch me become a monster. What value does this print to the screen? It is not a compiler error. That's what I'm saying. This is something called shadowing in C++. And so if you have two variables with the same name, it's allowed as long as they are not in the same scope. And you might be asking, but wait, you can just make a scope like that? Yes, you can. Yes, you can. No if statement, no while loop, just an open curly brace. I am not suggesting you write code this way at all. At all. So, yes, this will print, in fact, 420 to the screen. What if I did this? What is that going to print now? Where does that variable go away? Correct, when the scope ends. And so this guy no longer exists. So this is, in fact, going to print 42. Yeah. Because the 420 no longer exists. Good. Okay. This is called ScopeException. We're going one level deeper. What is this going to print? I humor myself sometimes. A lot of votes. What if NX42 wasn't there? Would X be 0? Up here. That one actually won't matter because that 42 is being shadowed entirely. If I delete that or put it back, it has no impact on the code because it's been completely shadowed anywhere it's being used. Good. Messick has it correct. So this is a hilarious example of bad C++ code. So only write this code if you don't want to be fired from your job, because if they fire you, then they will have to hire you again, maybe as a consultant at twice the rate, because you're the only person who understands this code. Okay. So this is setting the value of x equal to the value of x minus 100. What x is this? It's not this one. It's not. The nearest x is this one. So it is initializing a variable to itself. It is like saying integer x is equal to x. That is perfectly valid C++. I would never write it non-ironically outside of a classroom. But that is perfectly valid C++. You can initialize a variable to itself. What value will it have? Who knows? This is very much something called UB, which is undefined behavior. When you get into UB territory, the compiler can do anything the hell it wants. So let's find out what the compiler decides is a great idea. And we're probably going to get a warning. Yeah. Good. Pay attention to warnings. Pay attention to warnings. They're there for a reason. And a lot of students are like, well, it compiled. Let's try running and see if we pass the test cases. Pay attention to warnings. They are there for a reason. So we got negative 100. Okay, so it picked a value of 0 for itself. Now let's compile it again with the optimizer turned off. Okay. There's no guarantee that that is the value we're going to get. When I ran it in the previous class, I was getting like 29,000. There's just zero guarantees that that is, in fact, what the value you're going to get. There you go. See? So it's not random. It's printing out the value in memory, basically, but it's UB. And so when you have undefined behavior, the compiler can do anything it wants. Okay. So, yeah, if we just did this, though, then x would be 100. Okay, so all of this is just, it should hurt your brain a little bit. It's mostly C++ trivia, but it's useful for understanding people who write this code. Because this x here shadows the x up here. Do you guys understand? When you refer to x, just x unqualified by itself, it's the nearest one in the nearest scope. And that's the nearest guy in the nearest scope. This guy is in an outer scope. So it's not that one. So if you want to pick my x, you have to do something like this. And this comes up, yeah, undefined behavior. Like some people have, talked about like making a compiler that does like really nasty stuff when you do UB, so that you like pay attention to it. Like you can have a compiler that whenever you have UB, it like deletes your file system. So, high risk coding, right? The compiler can play the Macarena. The compiler can show a JPEG of Mike Tyson biting Vander Holyfield's ear off. That's all perfectly allowed under the C++ standard for undefined behavior. The compiler can do anything it wants, and that is a-okay. That's allowed. So, yeah, it's like high stakes poker, but high stakes coding, right? All right. Strong emotion linked to a listen generally helps with the retention of said lesson. Absolutely true. And that's one of the reasons why I use a lot of dad humor in these things, because you'll either experience humor or a groan. One way or the other, you're going to remember it. Okay, so... okay, so the third thing we need to do when we have a proper class assigned is getters and setters. So right now we can't actually access X or Y, right? Like there's no way, like if we said like point, P, passing in 3 and 4, like we can't actually print P.X, right? Because it's private. You know what I mean? So we need to make what's called a getter. A getter is a get function that will get the value of X. Now, if it's something simple like this, honestly, I would probably just use a struct like this. If it's really simple, structs are fine. But classes are useful for bigger projects, and proper classes are useful for bigger projects. And I'll get into a rant on that in just 1 second. But let me show you what a getter and a setter looks like. So if you want to get the value of X, we need a function here called getX, and it will return the value of X. And we are going to mark this as const. Only const functions, methods, whatever you want to call it, member functions can be called on const objects. So we have a getX, we have a getY, and then we will have a setter called setX. For X is equal to new X, and set Y, measure new Y, where Y is equal to new Y. And if you wanted to use this as well, you could name it X here, but I like doing it this way better than this way. Okay, so now we've got getters and setters. We're basically done with proper class design. So how do I call it? I say p dot get X, like this. Okay. So when you say p.getX, it's going to call this function up here called getX. It returns the value of X. And so what is this going to print to the screen, everybody? What will this print to the screen? Three. Very good. What if I did this? What if I did this? P.setX. What is P.getX going to print to the screen now? And I don't usually like cold brew, but this is actually pretty good. Yeah, it'll print 100. So the setter is essentially the equivalent of this, right? And the getter is essentially like saying cout p.x. Now you might be like, why? Right? And in fact, and somebody just said so before I even said that, why would you do this? It's just more typing, right? Like we have all of this stuff here, right? We've got all of this stuff here. This is like, how many lines of code is that? It's like 20, like 26 lines of code when we could have done 6, It's like way more verbose. So like, why on earth would we do proper, again with double quotes around it, right? Proper class design. So there is a reason. Now for a small project, I probably would just use a struct, honestly. And for something as simple as this, even in a big project, I might just use the struct. But let me motivate it for you, okay? So the benefit of structs, and remember structs and classes are interchangeable. But generally speaking, when I see a struct, as an experienced programmer, I assume you're going to do a pod, right? Plain old data. When I see the struct keyword, I assume you're going to be coding C world style, okay? Where you just have a bunch of public variables and things like that. Technically, you could do anything you wanted. Like you could, if I wanted to, I could make this a struct, all right? Just make this private. And this code is now no different than what it was before, right? The only difference between a struct and a class is structs default to public, classes default to private, that's it. But to the experienced programmer, when I see the word class, right? And when I see the word struct, I'm expecting pods. When I see the word class, I'm expecting an ADT, or proper class design. So an ADT is called an abstract data type, which means the people who use this code don't know how it is implemented behind the scenes. This is kind of like the main thesis for today. So this is why we do proper class design. Okay. So the benefit of structs is that they're faster to write, and oftentimes easier to read. Kind of the same way of saying it. It's less typing, right? Less typing. There's less typing. There's less reading. There's some default stuff for structs. Like you could say point p is equal to 3/4, and so you don't have to write a constructor for a struct. When you have plain old data, C++ will actually make a constructor for you. Nice. Okay. So you do that, or you can do this even, and it will just make a constructor for you. So it's just a lot simpler. Like you just use the defaults a lot of the time, and everything just kind of works. If you just need like 2 variables living under one roof, pods is probably the way to go. But now let's motivate the benefit of ADTs. I do not need a get thing for this guy. It's all public, right? Yeah, when everything's public, you can just be like .x, .y, and just do what we did back in C-Site 40. The trouble with this, okay, the benefit of proper class design is it makes maintainability easier. 90% of all programmers work maintaining code, not writing new code, right? They're usually working on an existing product. So when you go to work for Microsoft, you don't make a new Microsoft Windows from scratch, right? Like some people have. In fact, a friend of mine worked on a new from scratch operating system for Microsoft. But it's very uncommon. Like most of the time, they will put you on the team for PowerPoint or something like that, right? And so you've got this existing code base, and somebody's like, "Hey, I want you to add support for Arabic. Could you figure out how to make that work? Or could you make any right to left language or top to bottom language work in PowerPoint?" And you're like, "Okay, all right. So now I need to hack on top of the existing code base the ability to add a text that flows in different directions from English, right?" And so that's maintainability. That's a big question. So an example I usually use. Let's say that you're working at the Social Security Administration. This is an example I use a lot. And you've got a struct person, you got like a name, you got like an address, you got like Social Security number, SSNs fit within an int. But we're running out of them. Like we're actually running out of Social Security numbers. So at some point, they're going to change. We're also running out of time. I don't know if you guys heard about this, but like the time began on January 1st, 1970. And we got about 14 years left, 15 years left, until we run out of time. Like literally we run out of time. Because time is held in older systems as an integer. Integers have a maximum value of 2 billion and change. Beginning of time. Anyone know what the beginning of time was? The current epoch. January 1st, 1970 is the beginning of time, officially in the Unix standard. And so when we hit the year 2038, we're going to overflow the number of seconds since 1970, and it's going to wrap around to like 1901 or whatever, and everything's going to break. So yeah, it's like the Y2K problem, probably more serious though. The Y2K problem only affected people that were using the 2 digits for the year code instead of the 4 digits, which is the thing like in COBOL and things like that. A lot of people think that Y2K was a bust, like everyone was afraid for no reason. No, it was a thing. And a lot of my friends worked really hard on making sure nothing bad happened. And then afterwards, everyone's like, oh, they were just overhyping. And like, no, well, like we fixed the bugs, like we actually made sure that like nothing would break. Thanks, for nothing, and like there was no accolades for the computer science community's heroic efforts to stop Y2K. Everyone's like, oh, it's just a myth. No, we fixed it. We fixed it. Like even like they wouldn't allow planes to fly on New Year's Eve. Like I went out to downtown San Diego on New Year's Eve, 1999, and we're all kind of like walking around like, are the lights gonna go out? Like everything's just gonna shut down. It's gonna be total anarchy, and we're all just like, what's gonna happen? And then nothing happened. Right? The only thing that I got from Y2K was I got a letter from my bank saying, thank you for being a customer for negative 70 years or whatever. I was like, ooh. And I immediately logged on because, I mean, if your bank gives you negative 70 years of interest, like that's like exponential decay of your bank account to zero, right? So I very quickly logged on and made sure that my money was still there. And that part was, but the customer facing, the mail form or whatever it's called, mail merge or whatever, had the Y2K bug in it. That's the only time I saw a Y2K bug myself. I stopped Y2K and all I got was this shirt. Yeah. Some dude got charged overdue fees from Blockbuster. I imagine, but for anything that wasn't like mission critical, I'm pretty sure they're just like, we could just like let customer service handle it. You know what I mean? Rather than hiring expensive people to fix it. So that was Blockbuster trying not to go out of business. That's funny. Okay, so anyhow, yeah. So name, address, social security, and we are running out of social security use. And then we can have like an integer or a float for like height, weight, and let me be a little bit political here. And let's say that right now gender is a Boolean, and we're going to want to refactor it to become a string. Okay. So this is the kind of change that is being made around the world right now. Okay. So let me show you what the problem is. Okay, so let's say that this is the struct used inside of the Social Security Administration, and let's say that everybody uses a struct. Like you're over in like some other file now, like you're off like in, we're like in like some sort of like auditing code or something like that, right? Or like off in La La Land somewhere, and we've got this code, and the code says like person. You can be like if person gender, then cout person. We got like person p or something like that, right? So if p.gender cout p is a. Now you guys tell me which one's true, which one's false, men or women? Whatever you answer, you're gonna get in trouble. Yes. So we have one vote from Tipton. Tipton is saying men are true. Okay. So there you go. We'll just Tipton. There we go. Else is a woman. There we go. Now, so we're another group now, right? And this is what I mean by maintainability. If you have a large project, right? If you've got 50 different teams at the Social Security Administration, all working on different parts of the code, and they all use the same struct here. So let's say the group that's in charge of the implementation of this record, they're like, hey, we want to make a change, right? We want to let's I don't know, let's make this compilable code, audit or something. Person B cout p dot name. There we go. Okay, so we're off in a different code. Are you guys with me here? It's like one group of people is maintaining this. This is like, like group 1 over here, they're doing this part of code, and like group 2 is like over here. Okay. What happens when group 1 changes gender from a Boolean to a string? What happens to the entire code base with millions of lines of code that are all what we call tightly coupled? Okay, when you know the implementation details of a person, you know that the gender was held as a Boolean. What happens? That is absolutely correct, Alessandra. Everything breaks. So literally across millions of lines of code, every single place where p.gender appears now is broken. And so this team here now can't actually make the change they want to make, because if they change anything, it breaks everything. And so what you get is paralysis. You get institutional, I don't know what the right word is. It's like putting your entire code block on ice. Like you're frozen. Like you can't make bug fixes. You can't make feature improvements. You can't change things. And you want to change things to maintain your code. And so there's something called separation of concerns. These people want to be able to fix their stuff and not break other people's stuff. Okay? So watch what happens if we used a get function instead, right? So let's say that we were using name before. p.name, let's see here. Name. So let's say we're just like printing out their name, right? What would happen if we split the name into first name and last name? What's going to happen to everybody who knows how our person class is implemented? If we change that up and have in last name and first name, what's going to happen to everybody's code? All million lines of code. If they know how we implement a person. Compiler error. Yeah, it explodes. Okay. Now let me show you why this would work if you use proper class design. Okay. So if we had a name, let's put it back the way it was before, and this is all private. Let's switch this over to proper class design a little bit. I have a public section here, and we're going to make a little person, little constructor here, name is equal to Bill, or address is equal to 111 Main Street, SN is equal to height defaults to 3.1415 meters, I don't know, weight 100 pounds, yeah, okay. And if you're wondering about this syntax for a constructor, this is called the super cool awesome syntax. And what this does is this sets name to be Bill, address to be 111 Main Street, et cetera, et cetera. So this is a alternate way of doing constructors, and all the cool kids do it. So this is equivalent to saying person name equals Bill, address equals 111 Main Street. You guys understand? Like these two things are the same. Et cetera, et cetera, et cetera. Okay. So we got our constructor. We now need getters and setters. I'm only worrying about name right now. So we will have a string get name const return name here, and we'll have a void set name string new name. That should be passed in by const reference, of course. Say name is equal to new name. And let's just pretend that we have these getters and setters for everything else. So let's come back down here. We're in group 2 now, right? We're in group 2's code. So group 2, because they were using, you know, this proper class design all along, they're calling get name. Like that. Now, watch this. You guys ready for this? I'm going to replace name with last name and first name. Okay. See what kind of code it broke. And it's going to break things, right? It's going to break things. Whose code broke? Where are the red arrows? Is it in group 1's code or is it in group 2's code? You guys see what I'm getting at here? And in real life, it's not just group 1 and group 2. It's group 1 and 2 and 3 and 4 and 5 and 6 and 7 and 9 and 10 and 11 12. Right? And so the way we had it before, you would have to get all 50 groups working on this all at the same time to all make the change all at the same time across the entire administration so that you could switch out name with first name and last name. It'd be impossible in all practical senses. But if you do this, it only breaks your code. And you can fix your code easy. So what I can do is just fix my code. Okay? Because you do break things, like when you change things, stuff's going to break, right? So I can have last name, and I can add first name. Also Bill. My name is Bill, I guess. And then for get name, watch this. I can return first name plus last name. And when I get a new name, I'll just set, I don't know, first name equal to new name. And voila. The interface did not change. So the interface is still get name. And so the people who are doing the auditing code just call get name, and they call get name, and it returns Bill Carney, same as before. Like they haven't seen any differences. Duckman? What's Duckman? Oh, Bill, or what? Howard the Duck? Do you guys get what I'm getting at here? So if you keep your interface the same, the interface are these functions here, right? If your interface is the same, you can make changes behind the scenes as much as you like. And as long as the interface doesn't change, the people who use your code will not know the difference. And you are free to make your code faster, to fix bugs, to change variable names like we did right here. You can make progress. You can improve your code without having everybody in existence who uses your code to all update and break their code all at the same time. Okay. It's very, very powerful. And this is how you basically have to do it if you have any large projects at all. So we use getters, we use setters, and that creates a wall of isolation. It's called separation of concerns, right? The people in group 1 can work on group 1 stuff, and the people in group 2 can work on group 2 stuff, and they don't have to know each other's business. Group 2 doesn't need to know the internal name of name. Is it for name, first name, last name? They don't need to know any of that stuff. All they need to know is the interface. The interface, just like your functions, basically. The interface connects different teams. As long as the interface stays the same, you can change things without breaking everyone. Okay. You guys with me on this? So if you have a distance to function, you can change how, like, internally you're computing that. Like you can switch that out from, I don't know, square root to high pod or something. But as long as the interface of distance 2 is still the same, then nobody will know. Nobody will know. Classes equals strong control over changes. Structs are fast and dangy. I don't know what dangy. What is dangy? Dangerous? Potentially dangerous? Yeah. I guess. It's more like I use structs still. You know, like if I just need two variables together, I'll use a struct. It's fine. Like, you know, if I have to return like an XY location, like I will legitimately just be like struct location, int X, int Y, done. Like that's lit, and it's just two variables, and I can just take a, I can just take a location and return a location. It's just two variables, and it's fine. It's fine. It really is fine. Like there's nothing wrong with structs. The trouble is if you're getting into any sort of complicated system, now everybody's using this thing here. You can't ever change the name of X and Y. You know, like if you want to change X to be column and like Y to be row, you can't do it anymore. It's fixed. When you got 5,000 people all using, you know, .x and .y with stuff, you can't fix it. It's set. You know, like so. It's one of those things. Right? So, it's faster, easier prototyping. Yeah, but like I said, sometimes you just want two variables going together, and there's nothing wrong with it. Like it's fine. Like doing all this work with like gets and sets, it's a lot of extra typing, and it doesn't really do anything. If all you're doing is just returning X and setting X, like you might as well just make it a public variable. You know? It doesn't really do anything for you. But now like you know, here like I could change X to be a column, right? And I could change Y to be row. And if I did that, then beneath the hood, right, I can swap all these things out. And voila, I was able to change the name of the variables. Because there's separation of concerns. The people using my code are still going to call it get X and get Y. They don't need to know the details of my business. They don't need to know that I'm secretly calling it column and row. I could, under the hood, even change them from an integer to be like a double or something, right? Right? Maybe I had a float before, and maybe I want more precision now. So maybe I can just up the precision, and they don't need to know, because they're still getting integers. They don't know. They don't know how I'm doing my business, and that's good. Because if you have to know the business of everybody in the Social Security Administration, you will never get anything done, right? Okay, so that is my rant on proper class design. One last thing is pointers. So right now, there's kind of no use for a pointer. Like you personally probably have zero uses for pointers, but probably starting next week, you will. So I'm going to go through a little bit of the syntax on how pointers work and pointers to classes work. So if I have a point P here, I could say p.setX. If I make a pointer and set it equal to P, it's a pointer to a point. I can access X and Y the exact same way that I could with P. Except rather than dot, it's very, very close. If I wanted to access set X, let's say, through the pointer, and set X equal to 400, it's not dot, it is the arrow operator. So the arrow operator is a hyphen and a greater than sign. So this line of code here sets p.x to 100. This line of code here sets p.x to 400. It's literally the same thing. The ampersand here is the address of operator. It gets the address of a variable. And pointers just hold the addresses of other variables. And this is how you can access the original variable through the pointer. Okay? And this is where, Sarah, you should say why. Why would I do this? Because it seems like there's no point. I don't get it. Okay. That was what I was going to say, yeah. And you're right. There is absolutely no purpose for doing code this way right now. But what if you didn't actually have the original variable? all you had was a pointer. Well, then the only way you can access it is through the pointer, right? Like if you didn't have a variable named p at all, the only way you'd be able to change its x and y value is through the pointer to it. If all you had was a pointer to a variable, but that variable didn't have a name, then you have to use the pointer access. And that's what we're going to be studying next week. So right now, there's no use for you. Next week, and the rest of the semester, you're going to see there's a lot of this. So I guess the one thing you can do with it is if you're curious, like you could like look at the address of a variable. Like if you want to say, hey, what spot in RAM is P at? You can print it if you want. I'm not sure if you care. Like, do any of you guys care where in RAM your variables are? You care? Okay, well, fair enough. There it is. 7FF DA 0944D0. There you go. There's the spot in RAM where your variable is. I don't know what difference that'll make to your life. Was this a good day? Was this a bad day? Only the memory address can tell you the answer to that. So. To me, it's like, okay, cool. Yeah. That's the memory address. If we run it again, it'll probably be different, yeah. So press F in chat, right? 7FFFF. Press F to pay respects. Thank you. We get an F in chat for that. Thank you. So, in all seriousness, though, if you ever see a memory address that's like 7FFFFFF, that's actually the very top of RAM. That's where the stack is. Okay. So if I ever output the memory address of a variable and I see 7FFF, I know it's in the stack. It's a stack allocated variable. And that's sometimes useful. Sometimes you want to know if a variable is stack allocated or heap allocated. And so you just print out its address and tell. I don't do it very often. I have had some bugs, though, that were caused by people stack allocating things that should have been heap allocated. And that actually helped me debug it. Yep. How would you use the pointer? When would you use the pointer? You're going to use the pointer when you don't have an original variable at all, like that. That's when you use it. If you say new point 34, like that, you do not have this. P does not exist anymore. When you use new, and that's what we're going to be doing in data structures, there is no original variable. Okay? And so you can't use dot it at all. You have to use point. And so this is how you're going to be doing code in this semester. You're going to be newing things and capturing their pointer and then calling functions through the pointer using arrow operator. So this creates a new point. It's what's the name of the variable? It doesn't have a name. It doesn't have a name. It's a horse with a no name. I've been to the desert on a horse with no name. There is no name to this variable. The only way you can access the member variables and member functions and things like that when you knew something is through the pointer that it creates. So it feels good to be out of the rant. I know, right? We've had so much. So this is what you would do, like when you're newing things. And so you could set its x value this way. You could read its x value this way, and that's going to be printing its x value. That's going to print 400 to the screen. Prints 420 to the screen. Okay. So that's when you use it. And if you're curious what part of memory new stuff is, it's going to be around 5, I think, yeah. So anytime you have a memory address that spot in RAM that's around the 5 zone, that's probably the heap, which means it's something that's been newed. Anything that's stack allocated is going to be 7FF stuff. Okay. So it's occasionally useful to print out a pointer, just so you know if you're pointing at a stack allocated variable or heap allocated. It's usually not, though. We usually don't print out pointers very often. Okay. Any questions about this? Oh, there is one mistake that I've made here. Every time you have a new, you need a what? Yeah. So my code is leaking memory right now. Good. Every time you have a new, you need a delete. It's the rule of the Sith, right? For every master, there is one apprentice. For every new, there is one delete. Now we have balance of the force. Okay. We have a new, we have a delete. Everything's balanced. Yep. Delete frees up that memory. So when you new something, it permanently allocates until a delete is called. And then this frees the memory. You're probably not used to having to new and delete things because we normally stack allocate variables. Stack allocated variables automatically get allocated. They automatically get deallocated. You don't have to worry about them, right? If you say integer x equals 10, you've probably never thought about, okay, we need to make room for the variable so it has room to store its data, and then we need to clean it up later. And like, you just don't worry about it. This is a stack allocated variable. Gets created on function call, goes away on function end. Okay. So when main gets called, it automatically makes room for x. And so when you put a 10 in there, it goes into that spot in RAM. When main goes away, x gets deleted automatically. You don't have to worry about it. Okay. Heap allocated memory, though, can be much bigger than stack allocated memory. So you can't like exactly get away from newing things. New and delete are going to come up a lot this semester. A lot. CSI 40, you can almost get away with never using new and delete. In 41, though, you're going to be getting some info on it. Okay, so what I'd like for you guys to do now is for the next, I think this class runs till 4:20. Is that right? Deconstructor, yeah, we'll talk about deconstructors next time. You've got enough information right now to do the class playground. Dun, dun, dun. Okay. So, class playground. This is a little in-class exercise, but it is going to be graded on Monday. You should maybe be able to get it done now. But if you don't get it done during lab time, have it done by Monday. It'll be graded on Monday. I'm going to give you guys till 4:10, so you're going to have like 40 minutes, 44 minutes to work on this. And so it's got step 1, step 2, step 3, step 4, etc., etc. And it basically tells you what you need to know, need to do. So you're going to need to make a class called airplane. It's got to have public. We're not doing proper class design quite yet on this one. Class Playground 2 is more proper class design. This is just kind of getting you the basics into making classes. So you're going to have to make a class called airplane. It's got a public member variable called tons. That's an integer. A variable called cost that is a float. And then you have to make a pointer to comet. So remember the ampersand operator to get a pointer to comet. You have to write a function that takes no parameters and sets all the members of air pointer to false. You have to make a vector. So it'll give you some practice working with vectors and things like that. And so when you're working on this, you're going to be G++ing u.cc. And it won't compile until you get your class in. But then after you got everything done and you think you're like good with it, then what you're going to do is you're going to do a make clean and a make. And then it's going to run. This is kind of a cool assignment. I'm actually quite proud of myself for doing this. It's actually an assignment that tests your own code. It's like it'll actually swap out the main and then have a whole bunch of code that will call your code and make sure that everything's working properly. And if it doesn't, it'll tell you, like, you didn't do this part right. When you get all done, it'll say all tests passed and you're good to go. And you can bail out. Okay? So have at it. You guys got till 4:10. And then I'm going to come back at 4:10 and talk about SDF2, your next major homework assignment. This is a little lab exercise. It's going to be worth some points, not a lot. But your next major assignment is SDF2, Sign Distance Field 2, and we will cut back at 410 to do that part. All right, I'm pausing the recording now. All right, and we're back. So the last 2 minutes of class, I'm going to talk about SDF2. So SDF2 is the same as SDF1, but one higher. The starting point of SDF2 is basically SDF1. So if you haven't done SDF1 yet, I would get it done in the next 10 minutes or so because I'm going to grade it. Again. So let me show you what it looks like. So when you run it, it looks pretty same as before. You're going to make like a, I don't know, 30 by 30 grid or something. But now, instead of just doing asteroids, and if all we do are asteroids, it's the same thing. Like we can have a 1010 and a, I don't know, 2010, and it generates, there's 1010 and 2010, and it generates the same patterns as before, right? But we've got 2 new options now. We've got rectangles and we got circles. So circles are the easier of the 2 to implement, I would say. You're going to have to make a class for each one of these. So you're going to use some of the knowledge you got from today. The Zybooks also will teach you how to make classes properly. Circle's probably the easier one. And the reason for that is, let me show you. Let's put it at 1010 with a radius of 10. Why not? So, so at location 1010, that's the center point of the circle. It's that dot right there. I can select it. And then every square on the grid that is 10 units away from the center is marked with a asterisk. And then every square, every grid tile, every square, every space, I don't know what you want to call it, that is 1 outside of the circle is 1 away, and then 2 away, 3 away, 4 away, 5 away, 6 away, 7 away. It's actually really easy to figure out how far something is away from a circle. Does anyone know the mathematics behind that? Like if you have a point and you have a circle, how do you determine how far away the point is from the circle? It's a radius, okay, all right. That's part of it. You gotta have the distance minus radius, that's exactly right. And how do you compute the distance to the point? Which famous Greek religious figure made an equation that tells you how far away a point is from another point? Pythagoras, that's right. So if you have an x1, y1 that is the center point of a circle, you've got a radius, r. This defines a circle, right? So a circle is defined by a center point and a radius. That is a terrible looking circle. And then you've got a distance, like let's say over here somewhere. So the distance between x1, y1 and x2, y2 is the Pythagorean theorem, right? Which is x1 minus x2 squared plus y1 minus y2 squared. What is the name of this in the standard library? This is the d, the distance. The distance from here to here, d, is the square root of x1 minus x2 squared, y1 minus y2 squared. It's called not hypo, it is called high pot, because you get high on Pythagoras. So, that was, I think, a quiz question a couple days ago, right? So yeah, so as Alessandro said, if the distance is greater than the radius, then it is outside. And in fact, all you really need to do is just difference it. So you just take the distance and minus the radius, and that is it for this assignment. So like this point right here would be 11 grid squares away to the right. The radius is 10. It's 11 away. The radius is 10. So it is 1 outside of the circle. And then this one here is 12 away. So it is 2 outside of the circle. So it's just a high pot and a subtraction, and you're done. Now you might notice that there are letters on the inside. The negative numbers are represented by letters. Why? Because there's not enough room on the grid to print a negative sign. I was thinking about doing it with different colors and things like that, but I thought I'd just keep it simple. So A represents -1, B represents -2, C represents -3, all the way down to -9, which is I. Anything further than -9 away is a dot, which is the same as for anything further than 10 away in the opposite direction. So A is -1, B is -2, and so on and so forth. Okay. So you should be able to do that, hopefully, because you're given kind of some working code. Like, it's like the hardest part, I think, for people on SDF1 was actually just iterating over the grid, right? Like at every column, at every row, compute the smallest distance to an asteroid. Like that triply nested for loop caused a lot of smoke to come out of a lot of people's ears. For this one, the smoke causing ear brain melting function is going to be the distance to a rectangle. So if we have a rectangle and the rectangle is at location 15, 15, and it is 10 high and 10 wide, half height, half width. So it's actually 20 wide and 20 high. Then you will see that the rectangle here, all the squares that are 1 inside of the rectangle are all marked as A because they're -1. That is why it's a signed distance field. S in the signed distance field means that areas inside of the shape are negative. Okay, and this is useful in a lot of ways. We talked about it a little bit last time. I didn't upload it to YouTube because I didn't like my handwriting mostly on it. But when you have a signed distance field, you can actually compute the gradient, which is what I'm trying to draw here, right? If you have a -2 and a -3 and a -1, you can actually figure out that the edge there is something like that. And you can actually bevel the inside of a font and things like that to create cool font effects and things like that. This is how Half-Life does their font effects and things like that. And if you want to widen it, you can actually draw all the ones as well. You can actually make those part of the font outline, and so you can actually make your fonts thicker if you need to make them more readable. You can do anti-aliasing with it. SDFs are super useful. They're really neat, and for the inside of a rectangle, they're not too bad. Basically, you can see here as we go to the left, it's 1 away, 2 away, 3 away, 4 away, 5 away, 6 away, 7 away, 8 away, 9 away, and then this is probably 9 away from the top up here, and then we're at 10 away exactly in the center. So the inside's not too bad. The outside, though, gets a little bit tricky, and the reason for that is because let's do 30, 30, a rectangle at 15, 15 with a size of 4 and 4. You can see that when you're directly to the right or directly above, and same for the other cardinal directions, it's mirrored. It is just 1 away, 2 away, 3 away, 4 away. See that? It's the same as, there's no Pythagoras here. A lot of people try to do Pythagoras, from the center to here, but it's not, because the nearest point to here is just going left 4 squares, right? So if you're to the east of the rectangle, it's just anyone want to come up with the math for this? So if you have a rectangle and you have a center point here and you have a half width here, and the half width, let's say, is 5, and the point over here is 7 away, D is 7, and that's just the X value, right? You know the center, you know the half width. Yeah, that's what's entered by the user. So if you know that this person is 7 to the right of the center and your half width is 5 to the right, then how many tiles outside of the rectangle is this square? That's exactly right. So it's 7 minus 5, it's 2 outside, right? So if the edge is 5 away and we're 7 away, then it's just 2 outside. And then there's a similar thing up here. Let's say the half height. Let's say the half height is 3, and we are 6 north of the center point. If distance is 6, then we're 3 outside, right? The only tricky part is in the corners. And so if you're both outside on both sides, then you do the Pythagoras from this point here. What it amounts to. So your distance is going to be equal to the high pot from this point to I don't know, the corner or whatever. So that's the tricky part. So like I said, the hardest part on this is actually just because there's a couple different cases you have to handle. Am I inside? Am I outside? Am I to the right? Am I above? If I'm in a corner zone up here, then the corner zone up here, you compute the distance using Pythagoras. Whereas if you're just to the right or just north, it's just a subtraction. It's just the distance minus the half width, or the distance minus the half height when you're north. Okay, and these are all symmetrical. So I actually would recommend you absolute value your stuff. So if you have like a negative distance, like if you have a distance of like -7, then I would just absolute value it and turn that into 7, and then you only have to consider 3 cases: is the person to the right, is the person north, is the person northeast. And then you don't have to look at all the different corners and all that other kind of stuff. So that is the hardest function. So I would recommend doing that part last. Okay. So the location you're focused on has only one variable for distance. You don't have to use hypot. Yeah, if you're only east and not northeast, or if you're only north and not east, then you just do a subtraction. That's it. You only do a hypot if you're both north and east of the corner of the rectangle. That's the big thing. Okay. So there's like a bunch of different if statements in there. That's why you're going to have a week to do this. You can see out here, the corner is like kind of rounded off. That's because that's Pythagoras, that's hypot. Whereas when it's straight north, you see it just goes 1, 2, 3, 4, 5, 6, 7, 8, 9. When it's straight east, 1, 2, 3, 4, 5, 6, 7, 8, 9. Straight left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Straight south, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the corners that are Pythagoras. Okay. And I remember when we just used to add 2 variables. Yeah, that was last semester. So so if we do a 30 by 30 and you can mix these things together, you can have a rectangle, 15, 15, 10, 10, and then another rectangle at 15, 15, 1, 1. You can actually have one rectangle inside of another rectangle. And so you can see here, it's 1 away, 2 away, 3 away, 4 away, -4 away, -3 away, -2 away, -1 away. So if you have overlapping areas, it's whichever one is closest to 0 that you will output. And I've done a lot of it for you. If we check out STF2, there is a point class that is done for you. This is the old Asteroid class. And I've got lots of stuff in there for you to look at and learn from. If you want to learn how to read and write a class to see in and see out, there's some example code there. We'll talk more about that on Monday. There is a rectangle class, and the rectangle class is almost done. There is one function you have to do, which is the distance to function. So figuring out how far away a point is from us. And that's what we just talked about. It's this thing here. How far is a point from our rectangle? All the other stuff is done for you. You're welcome. It's got member variables already set up. This is not proper class style yet. This is still pods style, whatever. And then there is a circle class that you got to do the whole thing. Okay, and the reason why I have you guys do the circle class is because it's the easiest one, right? Figuring out the distance to a circle is literally d minus r, right? Like you figure out the distance to the point, and you subtract the radius, and that's the answer. So you should be able to do this. The operator the double left and double right operators are used for reading and writing things. There's 2 examples, one in point.h, one in rect.h. You should be able to use your critical thinking skills to make one for circle. If not, we'll talk about it on Monday. So that's your assignment. There's a little bit of stuff in main you have to do. Greetings, child. Ada, there's food for you on the coffee table. We're just wrapping up here. And so inside of main.cc, there's a little bit of vetting you got to do. You got to vet. There's a couple things that won't work until you get circle done, but mostly it's just vetting. So I've marked with you the areas where you need to do code. And that's it. You guys got a week to do it. Have a great weekend. I'll see some of you guys in about half an hour for the Build a Bear workshop. Sorry, Build a PC workshop. Peace.